Hey everyone! Today we'll be talking about StyleGANs. In this video, we'll discuss what image synthesis is, what GANs are, and how StyleGANs improve on certain aspects of GANs. First, let's talk about image synthesis. What is it, and why is it an important field in computer science? Image synthesis is the process of artificially generating images that aren't real. Think of image synthesis as the CGI you see in movies, or the character models you see in video games. Image synthesis is an important field in computer science because of the sheer possibilities that it allows different industries to utilize. In the past, image synthesis was done only by experts, those who create 3D models, renderings, or special effects. But now, with the increasing capabilities of deep learning, we're able to train a deep neural network to do what experts in the past did. This is where GANs come in.
What is a GAN? Generative Adversarial Network, also known as GAN, consists of a generator network and a discriminator network that try to best each other. The generator takes a vector as input, then uses a convolutional layer network to synthesize something, in our case, an image. The discriminator has two inputs, one of which is a database of actual images, and the other input is the generator. The discriminator does not know which input it received the image from, so its job is to figure out and output whether or not it thinks the image is real or fake. Neural networks are complicated, but we can simplify things a little in order to understand how the two neural networks of GAN work to learn from each other. In a GAN, the two networks are playing 1v1 with each other, and both are playing to win. Every time the generator generates an image that fools the discriminator uses that information to be better at deciphering which pictures are real and which ones are generated. And then, every time the discriminator figures out the picture was generated, it causes the generator to try to make a more convincing picture to trick the discriminator. Basically, they'll be competing against each other to get better together.
However, one weakness that a traditional GAN has is that you really can't exert any control over the images being generated. What if you wanted a really specific attribute in your generated images? For example, you want to generate a picture of an old, senile person, but the GAN just gives you a young child, or a middle-aged businessman. Here's where StyleGAN comes in.
StyleGAN, created by NVIDIA, tries to fix the problems we just talked about earlier. With StyleGAN, you can choose what styles you want to emphasize in your generated image. Remember the vectors we used for the generator? For StyleGAN, these vectors are special. They're basically the DNA for a generated people. That means, with the right vector, you can even generate a version of yourself and modify certain attributes, like gender, age, or even glasses. How did NVIDIA do it? How did StyleGANs manage to improve the GAN model? Something that StyleGANs do that a typical GAN model does not is progressive learning. Progressive learning allows the neural network to train on lower resolution layers first, and gradually increases the resolution as training progresses. Through this process, instead of jumping from one vector to a giant image, it breaks down the larger tasks into smaller layers. This causes the model to learn faster and be more stable while learning. Another component that is unique to StyleGANs is the way it maps the latent vector to a different space before generating the image.
For example, babies with facial hair do not exist in the latent space. So before we start to generate the image, we map the latent vector we receive by passing it through another neural network, which is also constantly learning as images are generated. This mapping neural network helps disentangle the latent space, so that any gaps that aren't represented in real data can be dealt with outside of the image generator, which means that the generative layers don't have to stretch their own latent space to fill the gaps. The last component is mixing regularization. Taking two latent vectors, we can mix the styles between them by applying one vector up to an arbitrary breakoff point, and then using the second vector for the rest of the mapping. By doing this, the GAN is able to generate images with some features from one vector and other features from the second vector.
Throughout the video, we only really discussed the ability for StyleGANs to generate people, but that's not all. We can also generate bedrooms, cars, and cats by training on their respective datasets. Basically, using any dataset that your heart desires and a StyleGAN model, you too can create images that can pass off as the real thing.